When a charge Q is given to a conductor, it spreads over outer surface of the conductor. The whole conductor comes to the same potential, say V. And here positive, 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 positive. This is. This potential V is directly proportional to the charge. This V is directly proportional to your charge. When the proportionality sign is removed and a constant proportionality 1 by C comes in the picture, then this becomes here V, this is Q by C. Now you can write C is equals to, that implies C is equals to Q by V. Here C is called capacitance of the conductor and the SI unit of capacitance is called farad. This is farad. 1 farad is equal to 1 coulomb per volt. 1 farad or 1 farad is equal to 1 coulomb per volt. Capacitor. Let this is a conductor and this is another conductor placed each other very close, then this system is called capacitor. One of the conductor is given positive charge. This conductor is given here positive charge and other conductor is given here negative charge. The conductor with the positive charge is called positive plate. This is called positive plate. And the conductor with negative charge is called negative plate. This is called negative plate. The charge on the positive plate is called the charge on the capacitor, and the potential difference between the plate is called the potential of the capacitor. The figure shows two conductors. One of the conductor has positive charge and other has negative charge, is forming a capacitor, and the potential difference between these two charges is called potential of the capacitor. Let us put a charge plus Q on one plate and a charge minus Q on other plate. The charge will appear on the facing of the surface and charge density sigma is equals to here Q by A. This is your areal charge density. Suppose that plates are large as compared to your gap between them or separation between them. That means any linear dimension of the plate is much larger than the separation. For example, if the plates are in a square in shape, the length of the side should be much larger than this gap. Or if plate is circular, that means diameter will be greater than this your width. The electric field between the plate is uniform and perpendicular to the plate except for the region of the near the edge. इस edge को छोड़कर बाकी region में that will be uniform. The magnitude of uniform electric field may be calculated as your Gauss's law. Using Gauss's law, you can evaluate the electric field here. Equals to E dot del A. Both are in same direction. That means theta is 0. If theta is 0, then cos 0 is 1. That means you can write this is E del A, cos 0 is 1. This is cos 0, and so phi is equals to E del A. You can write. And here del Q, that means here small charge in this region is your del A into sigma, and sigma is here del A into Q by A. You can write. Now from Gauss's law you can write E ds is equals to Q inside by epsilon. That means you can write from Gauss's law, you can write here E ds is equal to charge inside divided by epsilon naught, and here this region will be here E dot del A, that means E del A, and Q inside, charge inside divided by here epsilon naught, and here charge inside this will be E del A is equal to Q by A into del A from this. इस रीजन से ये del Q को हमने यहाँ लिख दिया. Charge inside is this and charge inside divided by here epsilon naught. That means this will be here this one. That means you can cancel del A cancel. That means E is equals to electric field is equals to Q by A epsilon naught. This is your electric field. The potential difference between the plate. Now the potential difference between the plate is here. Here V is equals to V plus minus V minus. That means positive potential minus your negative potential. And we have seen in earlier class, that means this is negative of E dr. We have already seen. And here E and dr is your vector quantity, and this is from A to B. You can write. And this will be negative sign. That means as one goes from A to B, the electric field and the displacement dr are in opposite direction. Opposite direction. Thus E dr is equals to, thus E dr is equal to negative of E dr. That means you can write. Here V is equals to, you can write. That means this is here. V is equal to, now this you can write here E dr, and from A to B you can write. माइनस माइनस कैंसिल हो जाएगा, तो हम इसको इस तरह से लिख सकते हैं. That means you can write ED and ED. ED को हमने यहाँ लिखा है, E को इसको यहाँ पुट करेंगे और D हम लिख सकते हैं यहाँ पर. That means this will be ED is equals to your potential, and this will be here Q D A epsilon naught. You can write. And capacitance for the parallel plate capacitor is equals to C is equals to your Q by V. That means here Q divided by this quantity Q D A epsilon naught. That means Q cancel. That means C is equals to, you will get the result. C will be here A epsilon naught by D. This is the capacitance, parallel plate capacitance. Now from this result you can see the capacitance is directly proportional to area and inversely proportional to your distance between the plate. So that the SI unit of epsilon naught may be written as farad per meter. Here we know that C is equals to epsilon naught A by D. That means here you can write epsilon naught is equals to CD by A. The unit of your capacitance is your farad, and this is distance measured in meter, and this is area is in meter square. That means meter square or ये meter, एक meter cancel. That means you can write this is farad meter per meter. This is the unit of epsilon naught. A capacitor gets a charge of 60 microcoulomb when it is connected to a battery of EMF 12 volt. Calculate the capacitance of the capacitor. We know the formula here. Q is equals to CV, and Q is here charge, C is capacitance, V is the potential. So here you can write C is equals to Q by V, and Q is given here 60 microcoulomb, and this is 12 volt. Now you can divide. This is equals to 5 microfarad. This is the unit of capacitance. So the capacitance of the capacitor is 5 microfarad.